Hello. Good afternoon. Hello, Jen. Can you hear me?
Yes, hello.
Hello. Yeah.
Oh, Aziz, is it?
Yeah, this is Aziz.
Okay.
How are you?
Oh, I'm good. You can hear me clearly, right? Can you?
Yes, I can hear you clearly.
Okay. Okay. So later, Aziz, I will share my
Yes.
screen at 2 p.m. At 1 p.m.
And one. Yes.
Okay, okay. Okay, so
I will introduce for maybe 1 minute per minute for.
can. Yes, no problem.
Okay.
Yeah. Then so Aziz, I see now we only have 3 people. Then is it later on there will be more people or?
Yeah. Later, Coco will join with on Budeni.
Oh, how about the customers? Will they join? What time will they join? Do you know?
In 1 p.m.
Oh, so 1 p.m. then they let the customers in, is it?
Yes.
I see. And so
Maybe you
Aziz,
can ask
yes.
the host in here from Lab Indonesia.
Lab Indo. Yeah.
Hello.
Hi, hello.
Hello. Oh, I think I'm going to respond for Yeah, and then yeah.
And Aziz, so later will you turn on your video?
No, I just.
Then should I turn on my video?
Can I can stop video? I can. Oh yes, I can.
Oh,
yeah.
Should
Maybe
I?
Introduce.
Oh, okay. Should I turn on my video also later?
Yeah, before you start your presentation.
Or how during my presentation do I need to turn on?
No need. Just off your video.
Because I think Davao yesterday, I think he turned on the video, I think.
Oh, okay. Up to you if you okay to turn on your video. Okay.
Oh, okay. I think I'm okay. Yeah. So maybe I will turn on the video. Should be okay, right?
Yeah, but I think maybe audience will not focus to your
not focus on the presentation.
Yes.
Oh, so okay. So you prefer if I don't turn on the video?
Yes, but if you finish the presentation, you can turn on the discuss.
Oh, okay.
Customer.
Okay, so when you introduce, should I turn on also, or should I? Then when I start, then I turn off.
Yeah, when I call you to please Jen to start your presentation, maybe you can start you turn on your video and you introduce yourself.
Yeah. Okay, then
stop the video and then you start your presentation.
Okay. Can should be okay. Okay, can. Thank you. Okay.
This is Siti Deniati is cocok account.
Oh, that's it, Corina. Oh, okay.
Yeah.
Okay, can.
Then... Yeah. You have a question for?
Yeah, I think I send you.
NA.
I send you.
WhatsApp.
Yeah, I send your WhatsApp. You can see the 2 questions there. Yeah, so if I think we only have maybe a few minutes for questions, so I think 1 or 2 is enough, should be.
Okay, yeah. I will read your question.
Oh, you.
If no attendant.
Okay.
Ask.
Yeah, can. And you, I think Aziz, you have to monitor the time also, because I think after 45, 46 minutes, maybe they will start to cut us off. So yeah, maybe you monitor the time. Yeah.
Yeah. Okay. Okay.
Yeah.
What to call you if or to confirm to you if time is 5 minutes or 10 minutes.
Okay. I think you just jump in and just turn on the mic and then tell me. Yeah. Maybe.
Okay. Okay.
If because I think I should take about 40 minutes. So if is much lesser than 40, like 42 minutes maybe, then yeah, you let me know and I will just quickly wrap up. But I'm hoping that it should be within around 40 to 41 minutes maybe, I think. Yeah.
Maybe you can turn on your stopwatch in your phone, so you can
also can. Yeah.
look.
Actually, because we start at 1 p.m. so yeah, I will just let me see, how should I do this? Okay, I will try to monitor on my end also. But yeah, I'm just worried that I may not be looking at the okay, let me try to put a timer maybe.
Hello, Caca, can you monitor? Hello, Caca.
Hello.
Hi, Corina.
Yeah.
Hello, good afternoon.
Hello.
Afternoon. Yeah. Corina, can you see the Q&A in the bottom of the monitor?
I can see the Q&A.
Okay. Maybe you can share the questionnaire form in the end of the webinar. It's
okay. The questionnaire form is that one, the link that you sent me.
Yeah. I sent you by WhatsApp before.
Okay.
Yeah. If I forget to share, maybe you can share, mention to customer.
Okay, so I should put the link in the chat box.
Yeah, in the end of the webinar, maybe 1 minute, 5 minutes before or 10 minutes before, we can share the link.
Okay.
Uh, 10 minutes before, you can share the link. But when, where we share, in chat box or in Q&A? Maybe in chat.
Yeah, I think in the chat, Aziz. Yeah, in the chat.
Yeah, in the chat. You can choose all finalists and attendees.
Yes.
Yeah.
Okay, so okay, you can see me now. What is this? Participants. Okay, so I will so Aziz, I will share my screen only when you ask me to start.
Yes.
Then okay, when you ask me, okay, so now I will leave my video on. Then you will do the introduction with my video still on, and then you ask me to start. Then I will maybe do
your presentation. And then you
will. I will just do a quick introduction, very fast, like 5 seconds, and then I will turn off the video and I'll start the presentation. Okay, can. Hopefully I remember to turn off the video. Okay. Okay.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, good afternoon everyone. Selamat datang di webinar kami. Saya Ajis Wibowo, mewakili PT Promtek Indo Utama, selaku distributor tunggal produk Waters di Indonesia, mengucapkan banyak terima kasih kepada Bapak Ibu sekalian yang telah bergabung di acara webinar Lab Indonesia 2020 ini. Kali ini kami akan menyampaikan materi dengan judul Introducing the New Premier Column, Maximize Analyte Recovery with MaxPeak High Performance Surface HPS Technology, yang akan disampaikan oleh Miss Jentan. Beliau adalah Chemistry Business Development Specialist Water Pacific yang berpusat di Singapura. Dan nanti bagi Bapak Ibu yang akan menyampaikan pertanyaan, silahkan ketik di Q&A, sertakan nama dan instansi masing-masing. Jika masih ada sisa waktu akan kami bacakan untuk dijawab langsung oleh Miss Jane. Tetapi jika nanti tidak terjawab, kami akan follow up by email. Jadi jangan khawatir bagi Bapak Ibu semuanya. Dan di akhir acara nanti kami akan share mengenai question form. Silahkan Bapak Ibu isi dan nanti kami akan kirimkan materi yang disampaikan oleh Miss Jane serta e-certificate berdasarkan questionnaire form yang telah masuk ke kami. Oke, mungkin itu sekilas dari saya. Oke, Jane, please start your presentation.
Okay, hold on. Let me share my screen. Okay. Okay, hold on. Okay, so before I start, thank you so much everyone for joining me here today. So my name is Jane and I'm the Chemistry Business Development Specialist from Waters Singapore. Okay, so let me just turn off my video and I will start my presentation. Okay, so again, for my presentation for today, I will be introducing to all of you the new premier columns that we have just launched at Waters. Okay, so what is this new premier columns that we just launched? What is so special about it? So the new premier columns, they all come with this MaxPeak high performance surface technology. So with this new technology in the premier columns, this can help to maximize analyte recovery, means that you will get better peak sensitivities, you get better peak shapes, as well as peak reproducibility as well. So in this presentation, we will go through and see how this actually helps with our analysis. So firstly, before I actually move on, I just wanted to ask if any of you are experiencing any of these issues, like limited sensitivity. So perhaps you see that your peak areas or your peak heights are very low for your analytes, or sometimes in some extreme cases, you may not even see an analyte. Or are you experiencing poor peak shape issues as well? Are you experiencing poor reproducibility? And are you performing time-consuming conditioning and passivation of your column and of your system? Or are you using undesirable metal chelating additives in your mobile phase? So if you think that you are experiencing some of these issues, you need to think about what type of analytes are you actually working on? Because sometimes some analytes can be more prone to giving you these issues. Why is that so? Because some analytes can interact with metals, and when they have metal interactions, that's when you observe all these issues that I just mentioned. Okay, so what happens is some types of compounds can interact with metals, and metals are present a lot on your stainless steel column. So what happens is, if you look at the diagram on the right-hand side, you have these types of analytes. So for example, analytes with a carboxylate group here, analytes with a phosphate group. So these types of analytes are extremely acidic. You can see that there is a negative charge on these analytes. So when there is negative charge on your analytes, if you have a metal surface, like whatever is found in your stainless steel column, your metal surface will have free metal ions. Okay, so these are positively charged free metal ions. And what happens is that your compounds, which are negatively charged, can now interact with your metal surface. So same thing even for the compound in the middle. You can see here, this is an amine, but as you can see, the nitrogen atom here, it's electron rich. So all these types of compounds, they tend to stick onto your metal surface. And when this happens, then you get the issues seen on the left-hand side, like whatever I mentioned earlier. Okay, so this phenomenon affects your sensitivity, your peak shapes, and so on. So what do scientists do to solve this metal interaction problem? So these are some of the current solutions that scientists are using in order to solve this problem. So the first case, you can see that they try to passivate the surface with an acid. Okay, so this means that they try to basically run an acid through the entire system and sometimes through the column as well. And what the acid does is that it removes any free metal ions on your metal surface. Okay, but the problem with this method is that it is often very time consuming, and you have to basically perform this passivation usually for a few hours, and you make use of strong acids as well, which may not be very ideal for your column. And also this process is not stable. So it means that once you have done this passivation, yes, you remove the free metal ions from the surface, then you inject your samples. And then eventually your samples will start to give you the same problems again, where it starts to tail, you start to get poor peak sensitivities and so on. And that's when you have to repeat this passivation process all over again. Okay. So this is one solution. Another solution is that to minimize that metal interaction, some people passivate the surface with sample or matrix. So what this does is that basically the scientists will inject many rounds of your matrix. And what this does is that the matrix will coat your metal surface. So you have a coating of your matrix on the metal surface to reduce that metal interaction. Okay, but again, this method is time consuming and it is often unstable, and you need to repeat this over and over again. Another method is to use, instead of using stainless steel columns, you use PEEK columns. So PEEK, yes, it is not metal, it is another type of material. So by using PEEK, yes, you are replacing metal with a non-reactive material. But just take note that PEEK itself, it is not high pressure tolerant. So you likely will not be able to find a UPLC column in PEEK. And PEEK materials, they are not as strong as compared to stainless steel. So PEEK themselves also have higher dimensional variability. So you may find that your PEEK column will change in terms of column dimension because they are not as strong. Okay, so this affects your reproducibility as well. And PEEK materials are not compatible with some solvents as well. Another potential solution that some people may think is that, okay, so I will not use stainless steel column. Let me try to use titanium columns. But remember, titanium itself, it is a metal. So it does not reduce that metal interaction because itself is a metal. So you will still get analyte loss due to metal interaction. Another potential solution is to use an industrial coating inside your column. So basically what this does is that you cover the metal of the inner surface of your column with a certain material, but this coating, it often leads to things like MS bleed. So you will often find things like ion suppression, or you find a lot of interferences in your results. And because this type of coating was never designed for LC or LC-MS types of application. And another potential solution, again, would be to use additives in your mobile phase. So this means that you add something inside your mobile phase such that this type of compounds will interact with the metal so that it prevents your analytes from interacting with the metal. Okay, so this is, yes, potentially one solution, but again, by adding additional additives in your mobile phase, you risk things like ion suppression, and also solubility issues. And of course, you need to constantly be using these additives in your mobile phase to prevent this problem. Okay, so these are some of the solutions that people are currently using, but as you can see, they are not ideal. They each have their own pros and cons. So this is when the MaxPeak high performance surface technology comes into play. So the MaxPeak high performance surface technology is found in all our new Premier columns, and this technology is designed to increase the analyte recovery, sensitivity, and reproducibility by minimizing analyte surface interactions that can lead to sample loss. So this is how it looks like. So now you have your metal surface. So all our Premier columns, what we do is that we modify our metal surface with a high performance surface technology, the MaxPeak technology. So this surface now is modified such that this minimizes the interaction of all these compounds with our metal surface. Okay, so all these issues that we talked about earlier on, we try to minimize them with the MaxPeak technology. So this is how it actually looks like in the column itself. So this is a standard column, right? So this is an ACQUITY Premier column. So if you see the word Premier, again, it has the MaxPeak high performance surface technology. So with this column, you can see that inside, we actually modify this surface with our MaxPeak technology. So now if you have an analyte inside your sample, it will go through your column and it will not interact with the metal, but it will fully interact with the stationary phase, which is the particles inside your column. And this is what you want to get better peak shape and also better sensitivities. Okay, so now let's look at some examples of how we can use the Premier columns for some small molecule applications. So this is an example. As you can see, we have some small molecules here. Some of them are neutral, some of them are acidic, some of them are basic. So they are quite different in terms of their physical and chemical properties. So now we have 7 compounds. And as you can see, we ran all the 7 compounds. So one of the compound is a void marker, and the other 6 compounds are over here. So what we did is we ran these 7 compounds on 5 different columns. Okay, so these are 5 of our standard columns. You can see it's the BEH column that Waters has. We have the CSH column and the HSS column. Okay, and we have them now in 2 formats. One is the standard stainless steel column. Another one is the Premier format, where we have that modification with the MaxPeak technology. So you can see now we have the 7 compounds run on these 2 formats of column. You can see that they all run pretty well actually, but you can see a drastic improvement, especially when it comes to peaks 2 and 3. So if you look at peaks 2 and 3, you can see that they are in red. So this means that they are acidic compounds. Okay, 2 and 3 are acidic compounds, 1 and 5 are basic compounds, 4 and 6 are neutral compounds. So the main benefit is, as you can see in acidic compounds, 2 and 3, you see that on the Premier columns, the peak shape is much better, much more symmetrical, and also you get higher peak intensities. So what is happening is really because acidic compounds, again, they tend to interact with your metal surface. So if you were to run them on a standard stainless steel column, you get some peak tailing, and you can see because of that, your sensitivity is lower. And for the Premier columns, because of that modification with MaxPeak, you see that it's much more narrow in terms of peak shape, much more symmetrical, and also better intensity. And because of that, you can see also that you get better resolution between peaks 3 and 4, because now your peaks for peak 3, it's much nicer, much more symmetrical, less tailing, so you get more resolution as well. Okay, and importantly, another thing that I wanted to highlight on this slide is that you can see when you run your samples on the Premier columns or on the standard columns, that the selectivity is exactly the same. The elution orders of your compounds are exactly the same. So you don't expect a difference in terms of your selectivity when you run it on a standard column or on a Premier column. Only that you expect to see a much better result in terms of your peak shapes, peak sensitivities, and therefore your resolution as well. when you run it on a premier column. So this is another example on organic acids. So any of you looking at organic acids, this is an example showing you citric acid. Okay, so we have citric acid here and isocitric acid. So these two compounds are very known to interact and chelate with metals. So you can see we ran these two compounds on two columns. The chromatogram in green is run on our premier columns. The chromatogram in red is run on our standard stainless steel column. So we have run it on two concentrations, 1 micromolar and 10 micromolars. So you can see on 1 micromolar, which is a very, very low concentration, that you don't even see anything on our conventional LC column at all, because everything is sticking onto the metal surface. But when we ran it on the premier column, you can see two very distinct peaks over here. And if I were to increase concentration from 1 to 10 micromolars, then you can see a small peak corresponding to the red normal LC column. So at higher concentrations, yes, you may be able to see a tiny peak, but same thing, when you run it on the premier column, you get two very distinct peaks. So this example shows you if you have a compound which is acidic, potentially may interact with your metals. And if you have it in extremely low concentrations, then potentially you get missing analytes. You may not even see that peak at all. So this is where really the premier columns comes into play. And this is another example showing you different types of acidic compounds run on the premier column. So you can see that in terms of the reproducibility of our retention times of all these acidic compounds, it's highly reproducible. Okay, so often if you have any non-specific binding with metals, for example, you expect that reproducibility will be a problem. But because the premier columns overcomes this issue, you can see that for all these very challenging acidic compounds, it gives us extremely stable retention times as well as reproducibilities. So those are just some examples of how the premier columns can help for small molecule types of applications. So now let's look at how the premier columns help with peptides, which are larger molecules. Okay, so any of you who are analyzing peptides, you probably will be familiar with its structure. So peptides are made up of amino acids joined together to form a chain. So that is a peptide. And you will also understand that some amino acids are acidic in nature. Okay, so you can see, for example, aspartic acid, glutamic acid. So these are acidic types of amino acids. So if you have a peptide which contains these types of amino acids, potentially it will make your peptide acidic as well. So let's look at the diagram now on the right-hand side. So you can see that in this diagram that we have three different peptides, okay? The peptide in black, it has its sequence over here, sequence of amino acids, and you can see that it has 0 amino acids that are acidic. So its acidic characteristics is 0%, the peptide in black. So you can see that the black chromatogram gives you a very, very nice peak shape, very narrow, and very little peak tailing. But as I increase the amount of amino acids that are acidic, now I increase it to 2 amino acids that are acidic in the blue chromatogram. You can see that this peptide now has 10% amino acids that are acidic. So as I increase the acidity of this peptide, I also increase the peak width. You can see it's broader now and it's starting to tail. Same thing as I continue to increase the percent of acidic amino acids now to 20%. So you see the chromatogram in red, it has now 4 acidic amino acids. So as I increase this percentage, you can see that now my peak is extremely broad and it's tailing very badly. Okay, so you can see that increasing the acidic characteristics of your peptide leads to increased peak tailing because now you have this peptide interacting with your metal surface as well. So now let's look at an example. So this is an example of a peptide called T37. So this is the sequence of the peptide. You can see that there are 4 acidic amino acids in the peptide. Okay, so this peptide is quite acidic. We ran this peptide on 2 different columns, one with the conventional stainless steel column, the second one with the Premier technology. And if you look at the zoomed up chromatogram, you can see that this peptide is tailing quite badly when we run it on the conventional LC column. But when you run it on the Premier column, its peak shape is a lot more symmetrical. Okay, we minimize that peak tailing. And that's when you can start to see the 2 very small deamidation impurities that is eluting out just after the main peptide peak. So this is the benefit of really using a Premier technology, that it is able to reduce peak tailing of your main peak such that it minimizes that tailing, and therefore it leads to better detection of any small impurities that may be eluting out right after your main peak. So this is another example on another peptide called T14. So if you look at T14, it also has 4 acidic residues. So it's still a very acidic peptide. So you can see when we run it on the 2 columns, the top chromatogram is run on a conventional column. You can see that the T14 peak is extremely tiny because you're losing recoveries to the metal surface. But when you run it on the Premier technology, you can see a very vast improvement in terms of the peak areas. And we are seeing approximately 35-fold increase in terms of your signal. So this is again another example on peptide mapping. So you can see again, this is a range of peptides being run on the conventional LC column versus Premier, the one with the Premier technology. So you can see that there is also T14 and T37, the 2 peptides that we just talked about earlier. So with T14, again, you get better sensitivities on the Premier technology column. With T37, you can clearly see that the peak shapes, because it's much better, that's when you can start to view the impurities much more visibly. Okay, and again, not just that, I also want to mention here that if you compare the profiles of the 2 peptide maps here, you can see that the profiles are exactly the same. Again, with the Premier technology, you do not change the selectivity, you do not change the elution order. The only thing that you change is in terms of your peak sensitivities, it's much improved, as well as your peak shapes are also much more improved. Okay. So this slide, it is another slide to prove that the Premier technology or the MaxPeak technology in our Premier columns is able to help us reduce the interaction between our analytes and metal ions. So here is an example, again on the T37 peptide that we ran on 2 columns. Okay, and as you can see, when we ran it on a conventional stainless steel column, you can see that we actually do see additional adducts in our chromatogram. Okay, so on top of our main T37 peak, we also see adducts, ion adducts of this T37. Okay, so which is over here. This second peak that we see on the conventional column is basically our T37 peak with an ion adduct. So why is there iron? Because your stainless steel column is essentially contains a lot of iron metal ions. So if any of them actually leach out of the column, then they can form adducts with your analytes. Okay, so this is why you see an additional adduct peak over here. But at the bottom, when you run it on the Premier column, because of that MaxPeak technology, that minimizes the presence of metal ions on the surface of your column. So therefore, it minimizes the risk of iron ions leaching out of your column, and therefore you see decreased amount of adducts. Okay, so this makes your analysis much more simple. Okay, so this is again proof that the Premier columns does indeed minimize that metal interaction between your surface as well as your analytes of interest. So we've looked at how the ACQUITY Premier columns works for small molecules, for peptides. Now let's take a look at how it works for oligonucleotides. So if you look at the shape, the structure of oligonucleotides, you can see that this is how it looks like. Okay, so oligonucleotides, they are large molecules, which as you can see in the backbone, you can see that there is a phosphate chain over here. Okay, so all oligonucleotides have a phosphate chain. So many phosphate groups, and these phosphate groups are negatively charged. Okay, so again, because they are negatively charged, they tend to adsorb onto metallic surfaces. So this leads to, again, the issues that we just spoke about: peak tailing, poor recoveries, carryover, and so on. So as you can see here, for this particular oligonucleotide, we ran it, it's called 20T. So we ran it on two columns. One is the premier column, one is the standard column. You can see that with the premier column, we are actually getting a 1.7 times higher signal intensity. Okay, so another example of an oligonucleotide is called GEM91. So GEM91, it's a very challenging oligonucleotide because it sticks very strongly to metal surfaces. So because of that, you can see that there is a huge difference now, very distinct difference in terms of your peak intensities. Okay, between the standard column and the premier column, we are getting 10 times higher signal intensities with the premier columns. So if you are actually looking at oligonucleotides analysis, this is the sort of experience you may be going through. So for example, now let's look at again the same oligonucleotide, GEM91, which is what we've seen here. Okay, this is GEM91. So it is a very challenging oligonucleotide. So because it binds to metals. So let's say now you have a brand new oligonucleotide C18 column. Okay, and this is a standard column, not with the premier technology. So what you will experience will look something like this. Okay, so you inject your first sample onto this brand new column and you realize that you see nothing. Okay, and then you start to inject more and more. Injection 4, 8, 12, you realize that you still don't really see anything in your chromatogram at all. You see that your signal intensities are extremely low, that you may even question whether your analytes, are they there? So you start to inject more and more. So from 8, you go to 14, 15, and that's when you start to see a tiny peak. So as you can see, your peak intensities are extremely low, even at injection 15. Okay, so what is actually happening is that your compounds, your oligonucleotides, from injection 1 all the way to injection 15, it has been, when you inject it into your system, into your column, it is conditioning and passivating your column. So this is when you are actually getting your sample to condition, passivate your column, such that it fills up or it binds to all the metals that it can bind to. And then finally, when you inject injection 15, so your oligonucleotides start to come out of the column because now you have conditioned your column. But as you can see, even at injection 15, your response is still extremely low. So many more injections will be required to increase this response that you get further. Okay, so this is what you may typically experience. And so what about if you were to use a premier column? So we ran the same experiment on a premier column. So as you can see, from injection 1 onwards, you start to see a very nice peak. Okay, so you can see injection 1, 2, 3, your signal starts to increase a little bit because you are still conditioning your column slightly. And then by the time you get to injection 6, 7, 8, that's when you can see that your signal intensities are extremely strong and it's starting to plateau off a little bit more. Okay, so with a premier column, what you get is better signal intensity, and you don't have to perform conditioning for such a long time compared to a regular LC column. Okay, so for now, what we have is that we have the premier technologies in 3 different brands of columns. So for any of you who are familiar with Waters columns, you know that we have column chemistries like the BEH technology, we have CSH, we have HSS. Okay, so these are our relatively more modern column chemistries that we have. And the BEH is really good for a wide pH stability. CSH is good for giving you better peak shapes for basic analytes. HSS is really good for maximum retention, especially if you have polar compounds. So these are our 3 modern column chemistries that we have. And we have them also now in the premier column range. So you can see we have the ACQUITY premier BEH columns, we have the ACQUITY premier CSH columns, we have the ACQUITY premier HSS columns. Okay, and we have them in small molecule formats, okay, the ones that you can use for small molecule analysis. We have them for peptide analysis, and we also have them for oligonucleotides analysis. Okay, and as you can see, we actually have one more column under the premier range, which I have not yet talked about. Okay, so this is the last thing that I will talk about for today. So this is called the Atlantis premier columns. As you can see, it is a different brand. It is not under the ACQUITY Premier series. It is under another brand of column that we have called Atlantis, but it is also a premier column. So what is this Atlantis premier column now? So if you look at the name, it is called the Atlantis Premier BEH C18AX column. So its name is quite long, but as you can see, it is made up of two different types of chemistries. One, you see a C18 group, and another AX group here, which stands for anion exchange. Okay, so this means that this column is a mixed mode column. So this is actually the first mixed mode premier column that we have at Waters. So why do we want mixed mode columns? So this Atlantis Premier BEH C18AX column, it is reverse phase because of the C18 group, and it also has an anion exchange, the AX group. And why is this important? Is because this type of column, it helps to give you improved retention of polar acidic compounds. So these polar acidic compounds usually can be quite difficult to be retained on a pure C18 column. So if now we have a column with an anion exchange capability as well, it can help to retain polar acidic compounds for a longer period of time. Okay, so this is why we have this column, to retain polar acidic compounds as well as non-polar compounds using the reverse phase function. Okay, so this column overall is good for retaining both polar acidic compounds as well as non-polar compounds. And as you can see, typically, if you have issues retaining polar compounds, some scientists choose to use reverse phase technologies, but then they find that it is difficult to retain polar compounds. So what they do is that they use ion pairing reagents or they use derivatization. But again, these solutions are not perfect. These options, they tend to have long equilibration times and may not be compatible with MS. And derivatization is also very time consuming, and you need to optimize this process as well. You could choose to use helic modes of separation, but again, it can be quite tedious in terms of equilibration. Ion exchange methods also possible, but you may not be able to retain non-polar compounds very well. So these are some of the options that people consider to try to increase retention of polar acidic compounds, but as you can see, they are quite tedious. So this is how the Atlantis Premier BEHC18AX chemistry looks like. You can see that this chemistry, the particle, the base particle is a BEH particle. So it's very good to be used in a wide pH range. And on the surface of this particle, you will see two chemistries. One is C18 here. So this helps to retain your non-polar compounds. And then you have an anion exchange group here, an alkyl amine group. So this helps to retain acidic compounds. So this overall particle helps to give you better retention for acidic compounds and also retains non-polar compounds. And it also gives you a different selectivity compared to a regular C18 column. And remember, so this column also is under the Premier brand. So this means that this column also contains that MaxPeak high performance surface technology, which then helps to also minimize any interaction between your metals and your acidic compounds. So again, this column is really good for acidic compounds because it helps to retain them for a longer period of time. And at the same time, it minimizes that metal interaction, okay, with the MaxPeak technology. So now let's look at an example over here. So you can see in this example, we have 6 compounds. 3 of them in black are neutral. 2 of them in blue are basic compounds. And compound number 5, adenosine monophosphate, it is an acidic compound. So we ran these 6 compounds on 3 different columns. So the first column here is the Atlantis AX column. The second and third column are typical C18 columns. So you can see that when we run it on the AX column, you get much better retention of the acidic compound because of the anion exchange group that we have on the AX column. Okay, but the compound number 5, the acidic compound, comes out very early on with the other 2 C18 columns because it is very polar. Okay, and another thing to note is that by running these compounds on the AX column, you actually do get differences in terms of selectivities as well. Okay, you can see that the elution orders are a little bit different. Okay, so if you find that you need more resolution between different types of compounds, you could consider a different column of a different selectivity because that can change your elution orders and that can therefore give you better resolution. So this is another example, and this is on a pharmaceutical drug, as you can see here. So this drug is called Chlorpheniramine Maleate. So this Chlorpheniramine Maleate, it has 2 components to it. Peak number 1 is the Maleate peak, which is extremely polar. Peak number 2 is the Chlorpheniramine peak, which is extremely non-polar. So if you run this drug on a C18 column, so the HSS T3, as you can see on the top chromatogram, is a C18 column. If you run these 2 peaks on a C18 column, you can see that it retains peak number 2 very well, but peak number 1, the Maleate peak, is too polar to be retained. So it comes out almost at the void. But if you were to run these 2 compounds now on the Atlantis Premier C18AX column, now your peak number 2 can be retained via reverse phase, that C18 group, and peak number 1, which was initially too polar to be retained by my C18 column, is now retained as well by the anion exchange group. Okay, so both peaks are now retained well with the Atlantis AX column. So then you may ask, is this Atlantis Premier BHC18 column only useful for acidic and neutral compounds? Okay, so as you can see, this compound that we have over here, this is a basic compound. Okay, and this compound, umefinovir, this is actually a very relevant compound now because this compound is used in inhibiting the growth of the COVID virus. Okay, so this is a basic compound. And as you can see, we ran it on 2 columns. One is the Atlantis AX column. One is on a HSST3 column, which is a C18 column. So we ran it on these 2 columns, and as you can see, both of them have retention. There is more retention on the HSST3 column, but as you can see, the peak is tailing quite badly. And this is because basic compounds like this, they tend to interact with the surface silanol on your particle. And when it interacts with silanols, that's when you get peak tailing. And if you run it on the AX column, so the AX column, remember there is an alkyl amine group. And this group, it actually prevents the interaction of basic compounds with the surface silanol. So because of that, the minimization of that surface silanol interaction, it actually minimizes that peak tailing. So therefore, for basic compounds like this, you can see that the peak shapes is extremely narrow, very nice peak shapes, and yet you also still get some retention because this compound can also be retained via that C18 group, the reverse phase retention. So to answer this question, I would say no. This column can be used on acidic compounds, basic compounds, as well as neutral compounds. Okay, so in summary, I just want to end off by saying that I've introduced to all of you the new Premier columns, okay, and how the Premier columns are really better, I would say, than our ACQUITY columns is that the Premier columns contain the MaxPeak high performance surface technology. And this technology, it really helps minimize that non-specific binding. And this kind of a binding can actually lead to things like poor sensitivities, poor reproducibilities, poor peak shapes, and linearity as well. Okay, so having that MaxPeak high performance surface technology minimizes all these issues. And how it does minimize these issues is because it helps to reduce any losses due to metal interactions. So it is extremely useful for peptide applications, oligonucleotides, and even some small molecule applications as well. Okay, and we've also got a very special column under the Premier range called the Atlantis Premier BEH C18 column. Again, this is the first mixed mode column that we have at Waters, which has both C18 ligand as well as an anion exchange ligand as well. So this column is really good for the retention of polar acidic compounds, and it also gives us better recoveries of compounds because it has that MaxPeak high performance surface technology as well. And at the same time, we can use this column for general acids, neutral compounds, as well as basic compounds also, and it's able to also improve peak shapes for basic compounds. Okay, so with that, I have come to the end of my presentation, and we will be actually taking any questions that you have.
Yeah, okay, thank you, Jane. That was a very interesting presentation. We have one question, Jane, in Q&A box from Mr. Joko Purwanto. Can we change the Atlantis DC18 to a Premier column without changing the method analysis?
Atlantis DC18 column to a Premier without changing the... Okay, so unfortunately, we do not have a Premier column in the Atlantis DC18 brand actually. So for now, currently, we only have it in the BEH, the X-Bridge BEH, the CSH, and the HSS. So unfortunately, for now, we don't have it in Atlantis DC18 yet. But in the future, we will expand it to other columns as well. But at the moment, we do not have it in Atlantis DC18 yet, actually. Does this answer your question?
Yeah, but if we have Atlantis Premier technology, can we replace the DC18 with a new technology?
Yes, so let's say, for example, now if you are using a certain column and you want to switch to the Premier column of the same chemistry, okay, for example, BEH, and you switch it to BEH Premier, yes, you can. So we have seen in a lot of examples that we do not change the selectivity. So the elution orders, everything is expected to be the same, but the only difference now is in terms of your peak sensitivities and peak shapes. You expect better peak shapes for that.
Oke. Mungkin itu Pak Joko. Jadi, saat ini kita belum ada untuk kolom pengganti Atlantis DC18, tapi mungkin awal tahun kita akan ada, dan itu tidak kalau misalkan nanti diganti tidak merubah selectivity. Jadi Pak Joko tidak perlu merubah metode analisis yang sekarang sudah eksis. Mungkin itu. Silakan jika ada pertanyaan lain, kami tunggu di Q&A box. And I have one question, Jen, for you.
Yes.
The Premier technology is a very interesting or a new LC column technology, but we know when we use this column, we can reduce or eliminate the metal interaction between our compound with the column packing, right?
Yes.
Yeah, but do I need to worry about the metal in my system, because HPLC have a metal in tubing maybe, and the other part?
Yes. Okay, so this, to answer your question, this depends on your compounds of interest, okay? So most of the metal surface in your entire system will come from your column, okay? So with MaxPeak, this solves the problem, but there will still be a little bit of metal surface in your system. So if you have a compound, that really interacts very strongly with metals in your system, then this is when you need to perform that passivation Okay, so you probably want to run acids onto your system before you inject. But if your compounds don't really interact so strongly to metals, you may be able to skip that step because most of the metal surface is from your column itself. So MaxPeak will take care of that. Yeah.
Okay.
Okay.
Okay. Thank you for your answer.
Okay. Thank you, everyone.
Tadi rekan kami sudah posting di chat box mengenai questionnaire form. Silakan Bapak Ibu isi questionnaire form, ini bisa diklik dari chat box. Nanti kami akan kirimkan. Maybe you can share the presentation file to us.
Sure. I will share.
Ya, nanti kita akan share presentation file dari DBN, and kita juga akan kirimkan sertifikat untuk acara webinar kali ini. Oke, kita masih ada waktu, mungkin sekitar 10 menit. Silakan Bapak Ibu jika masih ada pertanyaan. Oke, Jen. This is we have experience when we have additive compound, additive for mobile phase. It can impact to the chromatography result.
Yes.
So with MaxPeak HPS column, can we reduce the impact for the temperature or pH in my method analysis?
Reduce the what again?
Yeah, we can use with the for mobile with additive.
Yes, you can. You can still use the same method that you used with your previous method. If you want, you can try to reduce the additives also. If your additives are there to try to minimize the metal interactions previously, but then now with the MaxPeak, you may not need to add those additives anymore.
Oh, okay. Because when we use additive, can impact the column lifetime, right?
Potentially, yeah. Potentially.
Yeah, potential.
Yes. Yes.
Okay. So when we use this technology, we can use a method without additive.
Yeah. So only if the additive is added to minimize any interaction. Yeah. Then you can.
Okay.
Okay, so additives like EDTA, I just want to, for example, EDTA, that is one additive that a lot of people will use to minimize any metal interaction. So if you're using any of these additives, you can think about the premier columns.
Maybe some method for acid, they use TEA or DEA.
No, so those kind could be for ion pairing purposes.
Yes.
So if it's for ion pairing, it's more to increase the retention, for example, or of that compound. So it depends on what the additive is used for.
Okay, thank you very much. Presentasi. Mungkin di sini Bapak Ibu silakan jika masih ada pertanyaan atau ada.
Mohon maaf Pak Aziz dan
izin
waktunya sudah habis, akan segera saya tutup. Mohon maaf.
Oh, oke. Iya. Terima kasih kalian karena waktu sudah habis, jadi nanti silakan isi form, nanti kita akan follow up dari chat Bapak Ibu sekalian. Mungkin itu dari kami, dan thank you for your time, Jane.
Okay, thank you everybody.
Terima kasih.